Hey everyone, we're back with continuing on with Chapter 4 after our kind of history lesson, bringing it up to what our current idea is with protons, neutrons, electrons. So we've got our third energy level, or shell, we've got our second energy level, and our first energy level. Just kind of outlining some different ideas. Maybe if you remember anything with Bohr diagrams from previous years, that might give you a bit of a helpful part moving forward. So the structure of the atom is our main focus today. So when we take a look at the atom, it consists of three main parts. You've got a proton, an electron, and a neutron. And so our protons and neutrons, those are the guys that are inside the nucleus. Okay, so they don't really change or don't move around. They're stuck inside the nucleus. The electrons surround the nucleus on the outside, and they move around really quickly. They kind of actually make almost like a cloud kind of shape. So this table that's below would definitely be something that would be good to have in your notes to be able to refer back to. Protons, they have a charge of +1. Electrons have a charge of -1. So if I had an element that had 5 protons, I would have +5 charge. If it was just an atom, the electrons for that would then have, we'd have 5 electrons if you have -5 charge, so it would balance out. Your neutrons, they carry no charge with them. So the relative mass of our proton and neutron are both 1, and then that makes our electron, you can kind of get a sense of how light it actually is. So if the proton and neutron had a relative mass of 1, that means that your electron has a relative mass of 1/1840th. So it's teeny tiny. You can see the next one has location, so nucleus for proton and neutron, and then its orbit or its shell for the electron. The actual mass in grams of this stuff, you can see all the negatives that are there. Remember, a scientific notation, if you're unfamiliar with it, basically it's just saying this times 10 part is telling you how many places to move this little decimal. So it's saying in this case, take that decimal, and because this is a -24, take that decimal and move it 24 places to the left, filling in any empty gaps with zeros. And that's how small its proton and neutron are. Now, this doesn't seem like that much of a jump to go from electron to neutron or proton. Keep in mind it's that 1/1840th. So that's 4 extra place values that it has to jump over that the proton and neutron don't. So electrons, incredibly light, outside the nucleus, moving around. Elements, they're made up of one type of atom, and so the type of atom depends on its number of protons. That's how our table is classified. The number of electrons and neutrons in an atom can change, but not the number of protons. They stay the same. So for example, an atom with 6 protons, we identify that as carbon, and say an atom with 15 protons, we can identify that as phosphorus. The number of protons an atom has, that's also referred to as its atomic number, which sometimes you will see as coined the letter Z to represent the atomic number. Okay, it must be a whole number, it's not a decimal. We don't have parts of protons or neutrons or electrons, they're whole number values. After that, you can kind of take a look. There's a periodic table handout that goes along with this section, so you can print that off as well and have a copy of it. And in each box, you can kind of get an understanding of what each term represents. So we'll highlight a couple here. The atomic number of an element is the number of protons in the nucleus of an atom of that element. So here we're talking about iron, and the part that I've highlighted here, the 26, that tells you the atomic number. Right there, that atomic number of iron. It also works out to be that the atomic number is also the number of protons. So here we could say that iron has 26 protons in it. Okay, the total number of protons and neutrons in an atom is called the mass number. And so here I've got this highlighted on the bottom, that mass number 55.58. Now, it is a little misleading here because it says the total number of protons and neutrons. Well, if we identified them earlier as being whole numbers, how do we end up with this decimal answer? And we'll actually kind of get to that within this kind of set of notes, going through the idea of kind of a weighted average. And so really, I don't find 0.58 of an atom anywhere. It's more just taking a look at the different types of iron that are out there and taking a weighted average of them. So when you know the atomic number and the mass number, these can be used to find the amount of electrons, the amount of neutrons, and protons that are there in a given atom. So there's a standard rule here. Protons is equal to electrons, which is equal to the atomic number when we deal with atoms. So whatever I have, as soon as I find the number of protons, that is the number of electrons, which is the atomic number. To find neutrons, that's the one that's different. So neutrons is the mass number, and I should add it in here that it's the mass number that's rounded minus its atomic number. So we're never dealing with decimals. So for instance, if I were taking a look at sodium on our periodic table, I can see sodium is 22.9898. That's going to round. If I take it to the nearest whole number, it's going to take that 9 and bump this up to a 3, so it'll become 23. So number of neutrons is equal to the mass number minus the atomic number, which gives me 23 for the mass number, minus the atomic number for sodium is 11. So this tells me that I have 12 neutrons altogether for sodium. Okay, so protons is just the same number, there's no math involved there, and neutrons is just a subtraction. Standard atomic notation, ways that elements get written out so we can kind of quickly see some of the highlights of them. So normally what we do is we take the symbols of the element. So in this case we're dealing with aluminum. You can see the element symbol, Al, capital A, lowercase l. In the top left corner is always the mass number. It doesn't go in the bottom left corner, doesn't go in the top right corner. It has to go in that specific spot because each spot says something different when you start to place things in atomic notation. So the mass number, notice again that 27 is a rounded value. So it's the atomic mass, but it's rounded. And then we take the atomic number on the bottom, and then the symbol that's there. And that's all standard atomic notation is. It's just a way of us displaying the information quickly so we're able to find kind of the rest of the information in the problem. So there is a little activity on the bottom, worksheet on subatomic particles. You'll see it in the activity section. I would like for you to kind of move on to there, and then once you're done, we'll come back throughout the notes but continue in another video.